Hello, welcome to my video on carbon capture, utilization, and storage. My name is Carson. I am a chemical engineering student at the University of Florida, and the purpose of this video is to detail CCUS, carbon capture, utilization, and storage technologies, what carbon capture is, how they look in the modern world, and what their outlooks are going into the future with the problem they solve. So the current situation is that we are founded on a world of industrialization. There are a lot of great benefits that industrial processes bring to society, but they come at a cost. And most prominently in today's world, that cost is with greenhouse gas emissions, in particular carbon dioxide as a greenhouse gas. And as we can see on this picture on the left of this flow chart of the carbon cycle within society, there are a lot of points in which a lot of access points to the atmosphere with carbon dioxide, a lot of possibilities for emissions. So as a society, all of our additional processes have exceeded the Earth's natural tolerance for greenhouse gases, CO2 in particular. So it is carbon capture's goal to limit the emission of these greenhouse gases while still maintaining the benefit of these industrial processes. So what is carbon capture? Carbon capture in petroleum refineries, as our main solution in the modern day, is the method of identifying a emission point of carbon dioxide and finding ways to either limit the initial emission of carbon dioxide or capture it and store it or utilize it for another purpose. So that brings us to the flue gas expander, which is the primary technology that is being implemented into these petroleum refineries. So on the left side, we have this central cycle. That is the primary process seen with creating gasoline, gasification process. The way the flue gas expander works is it works in complement with this process. You can see this upper part here, how it ties into the cycle. That is the form of carbon capture that the flue gas expander exhibits. It's working in complement, capturing excess CO2 from the natural process and redirecting it, as you can see on the right side. It redirects the expander redirects this carbon dioxide back into the cycle to conserve energy from the initial process, which in turn means less carbon dioxide there's a lower net output of carbon dioxide, which is helping us achieve those goals. In past years, this technology has seen around a 25% reduction in carbon dioxide emissions just by itself within petroleum refineries. And going forward with carbon capture, there's a more aggressive approach with direct extraction methods. You can see here I have amine-based filters as one. Essentially, to extract carbon dioxide directly from the air, you need something that has a high affinity for it, and amines do that. They're very reactive with carbon dioxide, so they work great with extracting it from the air. Additionally, research on calcium oxide-based filters is also undergoing. The reason for it's still very affinitive for CO2, but its immediate product is a lot more sustainable for long-term storage, so which is why there is this thought in shifting from amines to calcium oxide. And regarding numbers, with current current reduction in emissions of carbon dioxide, we see around a 15% increase from a few years ago in 2019 to a couple decades ahead of us in 2050 with percent refinery reduction emissions in CO2. Likewise, the projected annual refinery CO2 emissions in megatons per year is also expected to decrease. You can see here in the blue how already with CCUS there is a big decrease, but that decrease is expected to increase as years pass. So some more insight if you're looking to find out more about CCUS. Academic literature, ones that worked really well for me were Carbon Capture Science and Technology in the Royal Society of Chemistry, their sustainability journal specifically. The trade literature, I have Hydrocarbon Processing and the Chemical Engineering Journal Advances. For consumer literature, I have Scientific American. If you're looking more into that direct extraction research, look at the academic side. If you're looking into how this stuff literally implements into society, like the process diagrams. That you can look at the trade literature. That'd be the best place. For consumer literature, it's a great place to start. If you're very new to this content, it's a great way to get involved. Scientific American's a really good option. My references for this video, if you have any questions about where I got my information from, I really appreciate your time and attention watching this. I wanted to thank you for sticking around, and I appreciate the view.